Hello everyone, this is your notes on domain and range of continuous graphs. Please make sure that you have your notes out from last week. If you need extras, you can find them in the classroom. We completed this portion of our notes, the 4.2 relations, domain and range, last week. This week we are now working with the second half of those notes. So the first piece we're going to do is identify what is a continuous graph. Each of these on this sheet of notes, those are all continuous graphs. Last week we had discrete graphs, which looked like the ones on your own questions, where you just have very distinct points on those graphs. So the difference here is that a continuous graph is a graph containing lines and curves. So it is not just points on a graph, it is more of a line or curve that is connected, and it shows a ton more points than you could just by plotting them on a graph. This shows a ton of different points in that pattern. This line here is made up of points and things like that. So what we're going to do for our domain and range, we have a couple different pieces. Remember, your domain are all of the possible x values that we could have on a graph. So think about your x-axis on our graph that we have. One way to find your domain for a continuous graph is just using your pencil to scan your pencil from left to right over your coordinate grid and think about what points your pencil is going over on that x-axis. So on this graph, you can see if I move the pen across, it is still touching kind of all the points along the x-axis for this function that is graphed on here. When I cover and we move our pencil across this one, some of these x coordinates here aren't being touched by our graph, but all of a sudden when we get to here, they are. And we're going to use, you should have 2 sticky notes. If you don't, please ask your teacher for some. We're going to use these rather than just scanning our pencil to help us with our domain and range. For the range portion, remember range is all of those possible y values in our graph, and our y-axis goes up and down. So we're going to scan our pencil from top to bottom to be able to identify those possible range values. So that's along our y-axis. So what we're going to do first, actually for the first graph, let's find the range piece. So the range, remember, is the possible y values, and that's going to go top to bottom. So I want you to grab your 2 sticky notes, and what we're going to do with one of them, we're going to start at the bottom of the graph, and I'm going to go up until I hit the piece that's graphed, and keeping it in kind of the top of it and lined up with the lines on that coordinate grid, that's where it stops. And I'm actually with my pen going to put a mark right there. With our other sticky note, if we start at the top and go down, we can see we touch one of those arrows, and because those arrows are pointing up, that means that this goes infinitely in this direction. So the y values from here, they just keep going on and on. We're going to get all of these numbers on the y-axis as long as we keep going up on our graph. So when we write our domain of this graph, or our range, sorry, because we're doing y values first, they're all of them starting where that sticky note was, going up. So we are going to write an inequality to represent this, and because it's the y-axis, we're going to use y as our variable. Those y values are greater than, because larger y values are going up, greater than or equal to, and where it started at, this point, at the origin, -1, -2. So all the y values that we are going to have are either -2 or larger than that. And that's what it showed when we placed our sticky note on our graph. We had starting at -2 and everything above that. Now if we look at the domain, so going back to those x values, if I put it on the left-hand side of the graph and I start to move it in, I get to one of the arrows here first. So that means that this range goes infinitely in this direction. So infinitely to the left. And if I go to the right with my other sticky note, I also hit another arrow. So that means that this arrow is just going to keep going this way. There's no kind of restriction on the right side. So because it goes all the way to the right, all the way to the left, then that means that on our x-axis or our domain, that is all real numbers. Okay, and our kind of notation for that, we use a fancy R. So 2 lines and then our R shape, and that's our notation to say all real numbers. So because it covered everything to the right and everything to the left, that's where that came from. The range, though we had a restriction, it never went below here, it was just here and above for those values. So we're going to look at the second one because you can tell it's quite a bit different. Let's do the domain first, so our x values. So that's our left to right. So on this graph, starting with the right side, if I start moving that sticky note in until I get to my graph, it actually does have a stopping point this time. So that's where that graph starts. I'm going to use my pen to kind of highlight that for you guys. And moving this sticky note in from the other side, it also stops at that point on our graph. So where we have our x values or our x-axis only goes so far this way and so far that way. So that means we're going to write an inequality for this one. So to show that, and if we count, this is 1, 2, 3, and this is 1, 2, 3, or -3 in that direction. So our domain is all the x values that are less than or equal to 3. So that's everything this way. But then we stop here, so our x values are everything greater than or equal to -3. So we can write that compound inequality to show that our domain is everything between those two values. And because this is a circle, we have something similar for the range. So starting top, if I move my sticky note down, you can see where it lines up there and it stops. And going up from the bottom, it also stops. So here, counting up from 0, 1, 2, 3. So our y values can go up to 3, and -1, -2, -3, go down to -3. So when we write our range, the inequality, we do have to use y for y values, or the y-axis. Those are going to be less than or equal to 3. So you have everything between here. Or they are greater than or equal to -3. So we have that same type of inequality written for both. One just has our y value restriction, the other has our x value restriction. Okay. I'll try one more, looking at this third one to the right. It's very, very similar as the other one. You can see if we go left to right, so I'm going to move my sticky note until I get to the first part of that graph on the right side and the second part on the left side. So I am finding the domain first because that was our left to right. This point here, if we count over from the origin, is 1, 2, 3, 4, 5. And this point here, it starts at -1. So when we write our inequality to represent the domain or x values, x is less than 5, less than or equal to 5, or it is more than or greater than or equal to -1. Very similar for our range. We're going to put that sticky note on the top, this one on the bottom, and kind of identify our two spots there. And this is 3 up, from our y-axis, and this is actually 3 down, or -3, kind of like that last example we had. So my range, we're going to hit all the y values from 3 to -3. So how we write that, y is less than or equal to 3, but it is also greater than or equal to -3. Going to example 3 in this bottom corner. In this one, if we move our sticky note in from the left, you can see right away that arrow extends into our sticky note, so that means it goes infinitely in that direction. And if I move my other one to the other side, you can also see that arrow extends infinitely in that direction. So that means all of the x values are going to get hit for this one. So our domain is all real numbers. And we can kind of put that, remember that fancy R for all real numbers. If we look at the range going up and down, if I go down with this one, I hit that arrow, and that arrow means it goes on forever, so it's going to keep going up in the y direction. And same thing if I go from this direction, from the bottom for our domain, or our range, it's going to extend and keep going down in that direction. So our range is also all real numbers. In the next graph, still going left and right, we can see the first thing I get to is those arrows on either side. This arrow is going to keep going down that way. This arrow is going to keep going down that way. So that means that because they keep going in both directions, infinite and infinite, our domain, we're going to hit all the values on that x-axis. So it is all real numbers, or that fancy R. And if we look at the range, so the y-axis going up and down, starting at the top, I do hit part of that graph, so I do have to stop there. But the bottom of this graph, it's just going to keep going down and down and down. So for our possible y values, we just have this restriction that it's from here and everything down or below that. So on our y-axis, we have 1, 2, 3, 4, 5. So all of the y values that are less than or equal to 5 are going to get touched by this graph. Our last example that we have, it kind of looks like this middle part, kind of looks like this piece, but because it goes up and down and then it goes back up, when we find our domain, or that left and right, you'll see that the first thing we get to is that arrow that just keeps going on and on forever. And on the right side, we also hit the arrow, not a specific point. So that means our domain is going to be all real numbers. And our range, going down from the top, we hit that arrow on the right side and the arrow on the bottom left. If I was trying to move those towards each other. So that means that our range is also all real numbers, because it doesn't stop at a specific point. It just keeps going on and on forever. Okay. What I'd like you guys to do is go ahead and try a couple of those examples on your exit ticket, or the on your own page. Try number 7 and number 8 first. So go ahead and pause the video right now and try those two, and then you can come back and check your answers. Okay, so looking at number 7, our domain first is our left to right along our x-axis. If we go like this, trying to shrink those in on our graph, we get to the arrows, and because the arrows show us going infinitely, our domain is going to be all real numbers. And the range, if we go top and bottom, we do have a restriction on there. It doesn't keep going in each direction. It kind of shows a pattern of stopping at a certain point. So where these stop, if we look at that, and then where these stop, all of our y values are going to be between two things. So we're going to have a compound inequality. So looking at what those are, this goes up to 2, and it goes down to -3. So for our range, we're going to have y values that are below or less than 2, and y values that are also greater than or equal to -3. Okay. Please, you should have tried number 8 on your own. Go ahead and try number 9 and 11 at this point if you haven't yet, and pause the video, try those, and then you can come back. All right, for number 9, what you notice for our domain, if we move our sticky notes in from the left, and this is the origin of the graph, if we move them in to the line that is drawn, I don't hit anything yet. The only time I get to something is right when I get to that line. So our possible domain values, this is 2 on our graph. So our x values that we have, they're always going to be equal to 2. So our domain, if we're just writing it as a set of numbers, is 2. That's the only x value that appears on this line. But our range, because if we go down this way, our range or y values is just going to keep going up. And our y values just keep going down. So your range is going to be all real numbers. The last one was a little bit different, so I'm going to go over that one. You can see it has a closed dot and an open dot. Remember what that meant with our inequalities. Closed dot, less than or equal to, greater than or equal to. Open dot, it was just less than or greater than. It wasn't included in those. So when we are finding our domain, if I go like this with our notes that we have, our domain starts at -2 and it ends here at 1, 2, 3, 4, 5 is where our last x value is. But when we write this inequality, we have numbers less than 5, and it's only going to be less than because it's an open circle. We're not including 5 in there. And then when we go to here, we have numbers either less than 5 or greater than -2. And this time it's a greater than or equal to -2 because that dot was shaded in or colored in. When we go this direction for our range, the first thing that we get to is 1 in that place. When we go up from the bottom, the first thing we get to on our graph is that open circle that we have at that point. And that's okay. We're going to stop there. And what that means is our y values are going to go between +1 and -2, but it's not going to include -2. So we're going to write that. Our y values are either down or less than or equal to 1 because there wasn't a dot or anything there, so we're going to assume we're including that. And they have to be greater than, not including, greater than, because my sticky note was here, -2. Okay. And that is the inequalities that accurately represent those ranges of numbers in that graph. Once you have completed your exit ticket, if there's any you haven't done yet, please make sure you finish those. Turn on your own questions exit ticket into the turn-in basket, and you may start on your 4.2 practice packet.